Hello, I'm Steve Loughran, Hadoop committer at Hortonworks. I want to give a quick walkthrough of the S3Guard work that's been going on top of the S3A connector to talk to Amazon S3. First, why all of this work? Well, the answer is I can go to Microsoft Azure website, hit a drop-down box and pay $25,000 for a petabyte worth of storage a month. That's the way things are going. Hadoop needs to play better in this world. The way it does that is by being better integrated with storage and through being more agile. I've been looking at the storage side of things. My colleagues have been doing agility. Here are some of the use cases that we're thinking about. ETL, where your data sources are running beyond the firewall, they're collecting data that's being stored in a container that's supporting uploads. Then, for an hour or two a night, you provision a short-lived cluster, brings up HDFS, it does all your processing there, takes that data, combines with data sources, and chucks out formatted data sets which you can then process more efficiently later on. Another use case, follows on from the first actually when you think about it, is actually using notebooks like Apache Zeppelin, like Jupyter, saving their own work to library, up and running, interacting with services running in cloud. The nice thing here is you can even choose which version of all your binaries you want to run. Again, working with the object storage, transient HDFS cluster for better performance close to the machines, close to the VMs, and persistent data sets. Final use case, far more advanced, and here I'm illustrating it running on Microsoft Azure infrastructure, is running a streaming application in. So we have external Wi-Fi sensors generating array records, feeding it into one WASB store. Along with that and the Microsoft Event Hub, we're feeding events into a streaming application, which is then processing it and saving it to HDFS. In this example, the Microsoft WASB file system can actually be used as a full replacement for HDFS because it has the full semantics of a file system that HDFS expects. That is not the case for S3. The reason for that is because object stores are not file systems. They've tended to focus availability and absolute cost over the consistency which we need. Also, they tend to be a bit slow. The main issue we've been worried about on S3Guard is a combination of performance and consistency. Key thing is a file system consists of a hierarchy of directories and files. Directories can contain files, files have data. Directories don't have data, you can't put a file under a file or a directory under a file. These things are so obvious they don't know mentioning, but in fact in object stores they're all untrue. In HDFS, we have a pool of storage nodes, the data nodes, which actually store blocks of a file system, blocks of files. And then we have the name node that actually stores the directory tree, the metadata. The advantage of this structure is we can do something. We can rename a file, we can rename part 01 from the pending subdirectory to the complete directory, and it happens as a single atomic operation in the name node. We can acquire a lot for that directory tree, update the fields, save them to the edit log, and then it's actually happened. The data nodes don't even need to know what's happened because they don't actually know the names of the blocks, they just know they have them. In contrast, object stores tend to take some function of the object name and map it to an object that's stored around the system. So there is no directory tree anymore, there's just names mapping to shards in the store. The other thing is, whereas HDFS we've tended to use replication availability of the block layer, the object stores tend to replicate at the individual block and lazily propagate the information around. When a new file is created, it trickles around. When a new old file is deleted, it can take a while for the tombstone markers to get around. And when a file is updated, again it has to propagate. Key thing is, copying takes time, and that's how we rename stuff. There is no rename anymore, there is only copy followed by delete. And it's important to consider because that is how we pretend rename exists. We made a lot of effort making the file systems, making the object stores look like file systems, but they aren't really. Rename is one of those places where, even though we make it look the same, the metaphor actually collapses. If you look closely, it's not real. Another piece of fun is that the API for interacting with these things tends to be HTTP. That's nice and simple, it's intuitive to understand, you're using gets, inputs and deletes and things like that. It's nice across platform. However, it can be very slow. You can't necessarily have a single channel open to multiplex IPC calls over it. Instead, you have to renegotiate things. It means some operations can be particularly slow and expensive. Final piece of fun, which is where S3Guard really matters, is that eventual consistency. I can get a piece of data, I can open a file, I get a response back. There's a load balancer there saying, yep, you can get it from shard 1. I can now issue a delete request. That will get routed somewhere to actually delete the data. And the file's gone, but it hasn't necessarily propagated all the way around. I can do another get, and I could get the old copy. I could do a head, I could even get cached status in the load balancer. In fact, on S3, apparently, the load balancer can even briefly cache negative lookups, which is a denial of service prevention feature, but it does mean that you don't even get a guarantee of great consistency. This is very dangerous. When I get back to that rename, how we mock renaming through listing files, copying and deleting them, we rely, if we can't list all the files, blobs that we need to copy, then we may not list all the data that a particular stage in a pipeline has generated, and therefore you're missing data that propagates, and then later on, way down the pipeline, you've got bad results there because data didn't get found because you're using an eventually consistent object store as the intermediate store of data. Don't you do that then? So, right now, people using object stores sometimes complain to us saying, hey, it's really slow to commit work to Amazon S3. And that's not really what they should be complaining about. It just happens to be the thing that people observe. Really, they should be complaining about saying, hey, it's really slow to commit work in Amazon S3. Oh, and by the way, sometimes all our data gets corrupted because you didn't see it. That's not so obvious, but it can happen, and that's what really scares us. So my current stance right now is without a consistency layer, you should not be using Amazon S3 as a direct destination of work. Alright, that's all you really need to know. Another thing that's quite slow, here's a flame graph of a query of some processing going on, TCP gets benchmark, where there are some big delays happening. It turns out that a big chunk of them are just calls to get file status. When we're doing queries, we're listing directories, we're partitioning, we're working out where the work goes. And it's a big upfront cost before stuff actually gets parallelized and executed. It's not a significant problem when we're talking to something like HDFS, which is very fast. But you hit the object stores, things suddenly get slower, and because it's the serialized phase of processing, it can really be a bottleneck. So, even your basic get file status and wrapped in is directory and lists, that can be really slow because we can do multiple head and list requests to see if something's really there. All the read operations because we're potentially giving seeks by breaking the open connections, and just listing files. Again, they're API calls, they can be slow because they may have to negotiate an HTTPS connection, even if there already is one we can reuse from a thread pool. There's still the time to parse HTML responses, XML responses. There is the fact that the API tends to throttle you if you're quite aggressive on asking questions. So, here comes S3Guard. 1, 3, 3, 4, 5. It's been done as a branch within the Hadoop project. It is now being up for voting to say, can we merge it in, which is why I'm giving a quick link in. Its goal is to provide fast, consistent S3 metadata. What does it do? The idea is to say, after I manipulate objects in the object store, then my list status and get fast status queries will be consistent. We also want it to be faster. We can get away with the faster because S3 itself is slow at the best of times. When it starts throttling you, it gets even slower. In contrast, DynamoDB, which we're using to store the metadata, you pay up front for an allocated amount of bandwidth, amount of IOPS. Once that's been provisioned, you can tell roughly how long it's going to take. Fully open source has been in collaboration with ourselves, Cloudera, we had some great input from Western Digital, Chris Roth, who's now at Disney, has been helpful, and lots of other people have been playing with it and telling us where we got wrong. It shows its heritage is actually the original work by Netflix, Semper, where they use mocking tools to put this in on top of Amazon's closed source S3 client. What we've done is fully open source and it is tightly integrated within the S3 file system. If you're using the S3 client, you turn it on, set up your database tables, and it will just plain work. What does it do? We're using Amazon's DynamoDB as the metadata store. I can query, say, does a file exist? We do a head request. I don't need to go to S3 to its load balancers. We just hit DynamoDB and we'll get an answer back. If I want to delete an object, I do it first in the object store, and if that's successful, take it out of DynamoDB. I can now do a head, it's been deleted, so it's up to date. And when I write something, I can do the same thing. Put it in the store, put it in DynamoDB. That means we do listings, we get a consistent view of the word. How do you actually use it then? You create a DynamoDB table in the same AWS region as your data and where your VMs are going to be up and running. The reason for that is if you don't do that, you get billed for long-haul connectivity. You turn S3Guard on in the clients, and if you want maximum performance, look at authoritative mode, although I think that's the one that needs most caution before we play. So, what do? You add a couple more settings to your S3A site settings to turn it on. There's a new property, FS S3A metadata store import, which says, here is my implementation of metadata store. The one we want for DynamoDB is the DynamoDB metadata store. There is the null one, and there's also one I use a lot for testing, which is a local DynamoDB server. As with everything else from Hadoop 2.8 onwards, you can configure this on a per bucket basis. So I set fs s3a.bucket, followed by the name of the bucket, then the metadata store import property. That will give me a per bucket setting. That's critical for saying, here are some buckets that I want C-guarded, here are some buckets that I don't care about. You then want to set the name of the table. By default, C-guard assumes that you're just going to be using a table with the same name as the bucket. It's nice and simple, it's a good way to get up and running. However, in a large production environment, we recommend having a single table that's shared among multiple buckets because it lets you share the IOPS, the provisioned I/O, amongst all the containers. It should keep the cost down, and it'll handle bursts better because you've got a higher absolute number. That said, you can tell Dynamo to actually, C-Guard to actually create the table on demand if you want to, by saying this table create option to bool, and then you can set the read and write capacities based on that. Like I said, share it, and you can keep an eye on the AWS console of what's going on. Once it's there, you've got a set of commands you can do. You look in it, you can import data, you can compare real world and DynamoDB table, and clean up and destroy it. Rather than talk about them, I'm going to give a demo. Here is a shell. I'm running Fish, the shell for the 1990s. And I'm about to paste in some commands there. If I can find the commands. Right, first thing we do is set some environment variables of a bucket and some data in the bucket. Now I'm going to list that bucket saying we're going to be using S3Guard. I do an fsls-r, and I'm going to set the metadata store implementation to be what we expect. I'm expecting it to fail here, saying I don't have S3Guard turned on. Correct. It says you don't have S3Guard turned on. It says I don't have it in the region EU West. I'm working with a bucket in Ireland. When you use the bucket name to talk to S3Guard like configure it, what it means is that S3Guard will, one, use all the FSS3A settings of that bucket as they're resolved with bucket settings, but it also means we'll look up the region and go, hey, that bucket's an island, you want your table in Ireland too. So there we go, EU West, one it is. So I need to create a bucket. Not a bucket, I need to create a table. So now I'm going to say S3Guard init, 5 writes, 10 reads, that bucket. Now it's going to create the table. Go to the non-existent table, the one that's not there. Here we go. I'll note that I'm doing this demo over long-haul links, the latency will be great. If you're actually deploying in EC2, the latency talking to DynamoDB will be a lot less. You'll still be hitting delays talking to S3 though, but what you will be doing is getting a lot faster bandwidth when you download stuff to S3 when you load stuff up. But because the copy command we use in rename is actually done in S3 itself, that doesn't get any faster. So we now have the table created. There's a diff command, S3Guard diff. I can say, show me the difference between the S3Guard repository and S3, and it says here are all the things that are in S3. We have directories and files, there's various stats. None of them are in S3Guard. If you actually start using S3Guard, it will actually start demand creating these files. However, we can speed things up by actually just doing an import right away. So the S3Guard import, it will pull it into the bucket, be it standalone or shell. There we go, 35 items. Now if I go back to doing a diff, it will not see any difference at all. There we go. So, everything's up and running. That's nice and happy. I can now do ls-r, and I'll be going through the bucket itself to see what happens. We're going through the table, it's going to pull stuff in. So there we go. We are talking to S3Guard, we're talking to DynamoDB. It's not obvious that we're going through the system. There's no obvious cues there, except that things will be faster. That's especially if you put authoritative on, things should be significantly faster, as it's saying, trust DynamoDB to be the scheme of record in terms of what's going on there. It's not visible here because we're going over a slow network and because we're not the actual setup costs of the command line are actually bigger than anything else. I will note that my colleagues, when we benchmark, we do see things are faster. Authoritative mode, it is really, really fast, but like you say, I think it's the one that has to be used with most caution. Now, like I said, the real thing here is you get performance, that's good, but the real issue is about consistency. So let's take an example where we have a look at where consistency is a problem. First, I'm going to bring up an IDE. This is IntelliJ IDEA. I've actually got a bit of a Scala test here. These are some tests that I have for cloud and Spark integration up on GitHub. If you want to play with them, drop me an email and I will send you a link to it. Effectively, it's how I'm testing things like the committer and regression testing stuff and doing some scale operations. So, this test, we create the file system, we create a test path, we delete it all. Then we create a new output stream under the path 0, part 0, write a word to it, says hello, and then we close it. Now, on a persistent file system, that will actually, it'll be there. Immediately we'll be able to list the file there, we do a list status, and it will be there so we can find it, then we can rename. That's what we're going to do in this code. We're going to we're going to list it, then we're going to actually list the final destination and we're going to assert it right. This is very, very similar to what's actually going on in the Hadoop MapReduce committers, where we do a recursive tree walk and then move and merge files in. Now, the way I'm going to show you this working, to say this really, really does work, is by actually turning on a little feature that gets bundled in the Hadoop AWS jar, which is the inconsistent S3 client. I'm going to run that unit test suite, S3 consistency suite, with the inconsistent client on. So let's run it with inconsistent optional. That turns on an inconsistent client under the S3 file system, where everything under the path delay listing me suddenly has delayed listing in directory listings in get file status calls, and when something's been deleted, it will take a while to go away, which can also be a problem when you're trying to work out what to rename, because it says, here's a file I want to commit, and it's not actually there. The next iteration of that same inconsistent client is going to do more fault injection. I already actually have it generating throttling errors and seeing how the code handles it. Shows me we need to do more in S3A there, but we'll also be doing more failures too. So here we go, here's the Scala test kicking off. I'm sorry it's taking a little while to start, but that's Scala and Scala test 3. And there we go, we got an orange error. We scroll back up and see what happened. It goes, there was no file committed. We looked in the work directory, that file wasn't there. So we got a failure. That's what happens when you have an inconsistent client. Now generally, in day-to-day use, you would not actually note that S3 is inconsistent. Here it happens because 1, we're generating all the time. 2, we're actually doing assertions to verify that things are actually consistent. If your code isn't looking for consistent behavior, it may miss it when it happens inconsistently. If you're lucky, you won't even notice that things are inconsistent, because just as a quirk of the execution and delays the execution, it may not actually show up. But the inconsistency is lurking there. All we're doing is guaranteeing in this world that it actually happens. Until I turn Dynamo on. Now I'm hitting the -D Dynamo. I'm going to put Dynamo on. Let's run the test now. And we've still got the inconsistent client, but we have DynamoDB as a consistent layer in front of it. What's going to happen is, even though the underlying client is being consistent with its listings, we aren't really going to care. Now let's wait and see. Because this inconsistent client actually ships in the Hadoop AWS jar, it's going to be free for anyone to use downstream for integration testing. You can turn on inconsistency, like I say, you have to turn on other errors, specifically throttling. This is going to make it really interesting to use. You'll be able to use it as a Chaos Monkey-like plugin in your own code. If you want to say, I can really handle an inconsistent file system, all you can do is say, I'm going to use an inconsistent client, give it a probability of being inconsistent, and just let it run. See what happens. And as I've shown, if you have it happen all the time, things will fail. still waiting for Scala to do its work here. Apologies. Look at the Maven test. Java test doesn't find any. No, it's going to Scala test. Scala is a great language for coding. I really like it. It's got hints of type inference. It's got some very nice features. It is dangerously hard to read other people's code if you're not careful. It's a bit like Perl in that respect. And it takes forever to compile. It's a small failure which I think people doing language design should never forget about. Anyway, let's come see what's happening here. The answer is, even though we've got inconsistencies, all is well. Our test passed. And the reason for that, of course, is that S3Guard recovered the failures generated by the file system. So that's what S3Guard does. We fix what goes wrong. So there we go. That's S3Guard at work. Actually, we're doing all the diff now. Let's see what's happening now. We might be able to see if we've got an inconsistent file system now. One of the funny things about using the inconsistent file system client is that actually it really complicates test setup and teardown. Normally when you test teardown, you want to delete all the files. That doesn't actually work reliably when the file system client itself is being unreliable. And here you see an example where there's some things in S3 that haven't been, they're out of the meta store, and there's some things in the meta store that aren't in S3. There we go. Anyway, I'm now going to destroy the bucket altogether. Sorry, not the bucket, the container. The S3Guard destroy command, it does take a bucket as a parameter. That's a bit disconcerting. But all it's really doing is working out all the settings from that bucket, but I still scared me using that name. I think maybe we should rename it to be something less dangerous, like destroy table, something like that. There we go. If you're doing testing of all the S3Guard code under Hadoop, you can run your tests. Every one with S3Guard turned on. And you can either use S3Guard with the local DynamoDB. Let's do it. Here is me running the Maven integration tests with parallel tests, 6 threads. S3Guard is turned on using a local DynamoDB minus the DynamoDB minus the OR. I'll skip the unit tests, I don't care about those. And we will kick off all the AWS integration tests running with S3Guard on. It's worth playing with this because you'll actually find your tests run significantly faster. Because of all that metadata caching, we don't need to talk to the remote endpoints quite as much. And most of the file system contract tests we're not working with large volumes of data. We're just creating files, deleting them, moving them around, doing all that kind of stuff, where the cost of accessing metadata is the main expense. So we'll leave that running. And we'll get back to the slides. There you go. There are the commands. It's now ready for merging in. We don't think it's perfect yet. We know nothing is ever perfect. But it's reached a milestone. I think it's ready to go. Holden works. We've actually been shipping a preview of it to some of our customers in the HD Cloud product. And we know that Cloudera have been doing something similar. Those are both backported to Branch 2 and Java 7. The current patch we have for Hadoop 1.3.3.4.5 goes into trunk, though it is actually something that will compile with Java 7 as well. If you look at what we're doing in terms of where I go next, the big one that I've been working on is the big Hadoop 1.3.7.6 committer. I should give a demo of that sometime. I'd like to improve diagnostics. I'd like to have a S3Guard info command, a little patch for that says, tell me a lot more about this bucket, about the table, its size, those things. I would like a lot more metrics. There are a few extra metrics related to S3Guard, but I'd like some more, particularly if we can do anything to actually assess the IOPS and load the generator. And I would like to do the usual stuff in terms of fault injection and scale tests. Even though we're doing fault injection at the S3 level, we have to do something similar for DynamoDB to see what's going on. One of the interesting things would be to see if we can get the metrics out the AWS library about when a DynamoDB connection is being throttled. If we can do that, that'll be interesting, because then it means you can answer the question, why is this job taking so much time, even though S3Guard's on, and we could look at the metrics and go, well, here's why you're being throttled. So there we go. There's also other issues. What about auth mode? Let's play with it a lot more before I trust it. What about read-only file systems? And like I said, there is a committer there. I would love people to come and play with that as well. I'll also point out there are lots and lots of open issues related to S3Guard. We have a big pile of them. Let's see if I can find the window. Here is S3Guard. Here is all the open issues we've got, and we have a whole stack of them. It would be great to have people come in and join them. A lot of these, they're more kind of like, oh, this is a bit annoying kind of thing. Like, I want to be able to tag the DynamoDB table it's created. So it's not the core features, it's the let's improve things as they go along. Those are the kind of things that you learn through use. We'll evolve them, we'll prioritize that kind of stuff. But right now, there are no real showstoppers that I can see. And there we go. That is the end of the demo. Like I say, S3Guard is going to be really interesting. For anybody wondering, do we need this with the other object stores? The answer is no, because Azure storage is consistent out of the box. Google Cloud Storage used to be inconsistent, but now that Spanner is being used as the underpinnings, it is actually consistent. However, the work that I'm doing with the committer stuff, which is relying on there being a consistent file system underneath as one of its committer options, that will actually is something that would be suitable for working with Azure and maybe Google Cloud as well, because it's relying on multi-part put operations not being materialized until you do a final post of what's going on. So the work there I'm doing, any fundamental changes I'm making into the MapReduce code and all the downstream tests I'm writing, they are going to be designed so they will work with the other object stores as well. The main thing is that for S3, 1, I want that consistent file system. 2, I need to do the thing on top to actually do the magic. Anyway, I hope you enjoyed this talk. And remember, most important thing of all, object